Let's extend the list of books with HTMX and add a database. If you haven't, you should first check out the video about building it without a database. We will use a really simple Postgres database, but the main goal is to show how to connect a common Lisp application to a database using cl-dbi. First of all, we add the dependencies. We will need cl-dbi, which is the core of the interface, sxql, which is a DSL to write queries, and dbd Postgres, which is the driver for Postgres. Let's load the dependencies again. Moreover, we need an instance of Postgres running. The easiest way is to start it with Docker, but you can also use an instance running directly on your system. When we run Postgres, we have to create a user, that in this case is Docker, set a password, which is again Docker, and finally the name of a database, which is Docker again. Moreover, we will bind the database to the port 54321. Then we can start to design the model and the main functions that we need to interact with it. We do this in a file store.lisp in the same package. We have also to add store to the dev system. We start with a simple macro that allows us to connect to a database. It will wrap every interaction with the DB. Then we write a function setupdb that will create the table. We will have to run it every time we drop and create the database. We use withDB to get a connection to the database. Then we create the statement using sxql. In particular, we are creating a table, which is called books, and it has two fields, ID, which is auto increment, and title, which will have a length of at most 128 characters. We can see that cl-dbi is a common interface but doesn't hide the internals of our current database. For example, in Postgres, to get auto increment, we will have to use the type serial, which is not portable across different databases. The function of yield will be more clear later on. At the moment, we just return its first value, which is the actual query, and pass it to prepare, which is the way to create a prepared statement. Finally, we can execute the query. Let's try if it works. Let's open a shell in the database to verify that the tables exist. We run psql with user docker to the database docker. We can see that it exists a table book. This table has two columns, ID and title, and ID is auto increment, as we would have expected. Inside this module, we will use sxql to make queries, but I don't want the user of those functions to be dependent on the result of sxql. So I'm going to define a class that represents a single instance of an element of my books. From the view, it doesn't care that we are using cl-dbi and sxql. We define a class dbbook that contains an ID and a title. Moreover, we define two generic functions, one to add new books and one to list all the books. Now we have just to implement those methods and make the view call them. If you like the video, subscribe to the channel to make it grow. To add a book, we have to use an insert into statement, always inside withDB. For the syntax of sxql, look at the official GitHub page. It provides a lot of examples for all the common requirements. In this case, we cannot ignore the second result of yield, so we use a multiple value bind. Yield will automatically separate the query from the values. This will make it easy to be safe against SQL injection attacks. Then we pass the statement to dbi prepare and the values to execute. Finally, we return that writing is successful if the number of changed rows is greater than 0. Adding is not enough. We have also to be able to list books. The structure is the same as addBook, also with the multiple value bind for yield. But in the end, we have to create an instance of book for each row. Here, we have to use a syntax that depends on the result from the database. In particular, the name of the attributes are lowercase keyword, so we have to use the pipe. This is the reason why I don't want to export this syntax to the user. Now we can verify that everything works from the command line. I move to the basic cl-dbi package. Inside, I add a book whose title is Harry Potter. Then I list all the books. We can see that there is an element, and if I inspect it, its title is exactly Harry Potter. Now we have to integrate the code inside the view. The book component is responsible to show all the books to the user. It will have to use the listBook function. Inside the list, we have to use listBook. And instead of the book itself, we have to show the book title. We can see that now the site takes data from the database. We have also to change the root addBook. Instead of a push to a list, it will have to call the addBook function. The value of the title is still get as a get parameter txtbook. That's it, everything else will work the same way. Now we can test that it works directly in the browser. I add a new title, stop the server, start it again. I forgot to save the file. Let's retry compiling, and if I reload the page, both books are still available, because the data was not stored inside the Lisp memory, but inside the database. From this point, one can easily extend this website to also delete or update books. You have to write the right method in the model and provide a route that allows to update. Let me know in the comments if you liked the video, leave a like and subscribe.